Welcome to yet another statistics video. My name is Bo Corkins, and this video is going to be all about means. So specifically, this video is about means and t-values. So we can use the t-table to find values for the t or t star value. However, you notice the t-table is quite restrictive. All right, it's not very big, and that's actually because it's only looking at 5 numbers. That's not very many at all. So even though the t-table seems very similar to the z-table, it is not. All right, we use StatCrunch. So basically, you can throw this t-table away. As nice as it is not useful. Instead, we are going to use StatCrunch. All right, I'm just going to open a blank page here. Stat calculators t. We did this for z as well. So the z uses normal, this uses t. And this basically is good for all degrees of freedom for all probabilities. So what we want to find specifically, using the t-table software calculator, we're going to use StatCrunch, the critical value t star for 95% confidence was 7 degrees of freedom. So with 95% confidence and 7 degrees of freedom, so 7 degrees of freedom, which means the sample size was, and we should be able to actually, we could do between here. So 95% in the middle. 95% in the middle with 7 degrees of freedom, which means the sample size was 8, because degrees of freedom is n-1. So that gives us negative 2.3646, or what I have written as negative 2.365. All right, rounding that to 3 decimals. I rounded that to 3 decimals because this one, the t-table actually will find. Down to 7 degrees of freedom and over, all right, 95% is this middle column. 95% gets me 2.365. So the t-table does find it when the sample size is low and I'm looking at one of these 5 possible values. However, let's change it up. I want to find the p-value for t less than 2.19 with 41 degrees of freedom, which again, just as a note, that means the sample size was 42. And so in this case, all right, 41 degrees of freedom. So just to look at the t-table. So 41 isn't even on here. This column on the edge is degrees of freedom. It goes 40 to 45. With sample sizes, you always round up, so I have to go to 45. And then I'm looking for 2.19, which isn't even on here. So the best I can say is it's in between 1% and 2.5%. That is just a horrible guess. So to StatCrunch we go. Looking exactly 41 degrees, 2.19. Let's start with greater than. And the probability, the p-value is 0.0171. So the greater than one is the one we started with. And then 1 minus that gets us the less than, but again, StatCrunch will do that for us. All you have to do is switch the inequality. 9829. So we can find the p-values exactly using StatCrunch, all right, with the calculators command, and that's what we're going to do. Don't use the t-table. It's far too approximate. All right, along those lines, let's look at an example here. A random sample of 9 men's GPAs was taken who responded to a survey. The average GPA of the men was found to be 3.02. with a sample standard deviation of 0.537. Find a 95% confidence interval for the mean GPA of men. So we're doing a confidence interval, and we're doing it about the mean. So we do not have data, but we have summary statistics here. Very first thing we do is check our conditions. Large enough condition. The sample size is 9. That is less than 30. Fail. Fail, 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 fail. However, with means, it's an OR condition. The nearly normal is the other condition, and the histogram here looks unimodal and symmetric. With a unimodal and symmetric histogram, that means we can assume, all right, normality. Now, here's the best part. So, the calculations, stat T statistics, one sample with summary, because we have the summary statistics. All right, we were given the sample mean, which is 3.02, sample standard deviation 0.537, and sample size 9. We're not doing a hypothesis test, we're doing a confidence interval. And then, all right, hit compute. So that gives us the upper and the lower limits. All right, it does all the calculation for us. 2.61 to 3.43. All right, which is what I've written right here. Our concept is still the same as it's been. Estimate plus or minus T star times the standard error. Okay, that's practically the same thing we were using for proportions. We just have T star instead of Z star. But my point is that this basically means I can do this whole thing, all right, in StatCrunch. Then the only part we have to do is interpret. We are 95% confident that the true average male GPA is between 2.61 and 3.43. And if I had units, I would put them, but the units of GPA are just GPA, so feels redundant, right? But if it was dollars or whatever. So again, check your conditions, use StatCrunch to calculate, and then type your conclusions up, write your conclusions out. All right? T statistics are actually much, much quicker, all right, than Z statistics, because StatCrunch is going to do all the calculation for us. Along those lines, let's look at another example. So, many Californians have trouble speaking without using the words dude or like. So, a company has developed a handbook and audio tape to help Californians overcome these speech impediments. We want to see the number of times dude is said by Californians per hour has decreased. We believe that all Californians say dude 23.3 times per hour. After completing the program, the company tests the book/tape package, all right, on a random sample of 40 Californian residents. The data is in the means activity in StatCrunch. So, first things first, write out our hypotheses. HO, the null hypothesis, mu equals 23.3. That's our assumed proportion right there. Then less than, because it says decreased. All right, so we're trying to see if it has decreased. Then check your conditions. Large enough condition, the sample size is 40 Californians, which is greater than 30. So that condition is met. However, we could also check the nearly normal condition. Let's go to StatCrunch. So we need to go to our data sets. And so in data sets, just search for Bo Corkins. Means activity there, right there. And it's the California column, in case it wasn't obvious. And I'm going to make a histogram. And that looks pretty unimodal and symmetric. All right, not perfect, but again, pretty unimodal and symmetric. It is approximately normal, hence the conditions are met, and we may assume the sampling distribution of X bar is normal, with a mean of mu 0 and standard deviation, which will need to be calculated. But again, StatCrunch is going to do all that for us. So, stat T statistics, one sample with data. This is the best part here. Stat, T-stats, one sample with data now, all right, because we have an entire column of data. So we don't have summary values anymore. Put in California, 23.3 and less than. We don't need any other plots. Compute. Gives us the t-statistic, which is 0.186, and a p-value of 57%. That is what I have written right here. Again, StatCrunch does all the heavy lifting. There is no calculation for us to be done, which again means we can go directly to the conclusions. Let's start with our decision. Remember the rule. If the p-value is less than alpha, then reject HO. So in this case, 0.57, that is greater than our standard 5%. So hence, I'm going to fail to reject HO at a 5% significance level. Then I state there is weak evidence, all right, that the true average number of times that dude or like is less than, all right, that times that Californians say dude or like is less than 23.3 times per hour. There is a 57.33% chance that we would randomly observe 40 Californians that say dude or like an average of 23.48 times with a standard deviation of 6.025 times. Actually, let's take a moment and pause. How did I get that? In StatCrunch, right, the mean is presented right here, 23.48. However, that's the standard error, not the standard deviation. Recall, summary stats, columns, California, compare. The mean, 23.48. Standard deviation, 6.025. All right, so again, StatCrunch provides all the info we need to make a full interpretation. Times per hour, if the true average number of times Californians say dude or like was actually said, all right, to be 23.3 times per hour. Again, times per hour is the units there. All right, so, all right, the difference in the interpretations here between what we were doing in proportions, all right, and what we do in means is it's not percentages anymore, all right? Everything has context, units. And that's what we focus on the most is our units. All right. How many Californians must we collect to have 95% confidence of estimating the true mean within 1.5 times of saying dude? All right, so hint, this means the margin of error is 1.5. Hint, as the sample size of a t-distribution increases, it becomes a z-distribution. So this t star can be used as z star. So we know z star for 95% is 1.96. I then know the standard deviation, which we just found is 6.025, and the margin of error is told to us to be 1.5. This calculation, right, is at the end of the lecture notes. Plug it in, and then with sample size calculations, always round up. All right, always round those calculations up. All right, so we can work backwards, all right, with sample size calculations for means, just like we did with proportions. Notice, confidence intervals, hypothesis testing, sample size calculations, all of it for means and proportions is very, very similar. All right, hopefully that is helpful and that covers everything. Feel free to review the notes and let me know if you need anything. Thank you very much.